Welcome to WDD's HotSpot. I'm Mike Luciano, Associate Editor, and in this week's episode we have how to use Bluetooth to bow hunt, a self-balancing motorcycle, and a 1D printer that creates a wire robot army. Trophy hunting has been a centuries-old pastime in the United States and around the world. It shouldn't come as a surprise to many of us that this particular sport and industry has experienced its own set of innovative technological advancements. Insert the ProTracker, a Bluetooth-connected hunting arrow that's described as being the ultimate recovery system for hunters. Developed by Breadcrumb Trackable Technologies, the tracking system works efficiently regardless of terrain, weather conditions, or having no footprints or blood trails to follow after you make a hit. The ProTracker has been tested by experts in the archery industry. Its compact system allows users to track up to 6 different transmitters at once using the same receiver. You can recharge the transmitters at home or in the field and will see virtually no difference in the arrow's trajectory because of the aerodynamic carrier. Thorough testing by industry experts has proven the arrows will only have a slight difference in trajectory, and by practicing on dummy targets you can adjust your equipment and become proficient in using the system. One of the best parts about the ProTracker is that hunters won't have to detract from their preferred method of scoping out targets, whether it be in a tree stand, a ground blind, or stalking their favorite trophy animals. The ProTracker helps locate kills quickly, accurately, and can give you several hours of top-notch usage. BMW's motorcycle of the future is capable of self-balancing, which helps the driver avoid crashes or wipeouts. Known as the BMW Motorad Vision Next 100, some even say the motorcycle's self-balancing feature is so effective it might mitigate the need for helmets and protecting padding altogether. Concepts of BMW's self-balancing motorcycle have raised several questions about how truly capable this vehicle is of achieving everything it's reportedly capable of. Questions that the unveiling of the first prototype for BMW's 100th anniversary should largely answer. The Motorad's self-balancing feature only requires the use of a kickstand when the vehicle is shut down, and the bike has an electronic safety cage that's capable of communicating with other vehicles. The Motorad is powered by a zero-emissions electric engine that still has the famous shape of BMW's flat twin engines with the cylinders protruding from both sides. The bike's flexible frame can bend as the bike is steered, which eliminates the need for joints. While the amount of power required to steer the bike varies with the motorcycle's speed, the Motorad is light and easy to steer when moving slowly, but requires more force to maneuver as the speed increases. The Motorad doesn't come paired with a helmet, but instead uses a pair of interactive goggles that not only keeps bugs and debris out of the rider's eyes, but streams real-time data between the vehicle and rider as well.
When you think of robots, usually a complicated network of gears, electronics, and wires comes to mind. However, this doesn't always have to be the case. Researchers at IT University of Copenhagen have centered their robot design on simplicity. They've created a printer that produces extremely simple robots on demand. Plus, the little creations can do tasks beyond human capabilities. They call their device a 1D printer, since it can pump out wire-based robots that can reach locations humans can't. Similar to industrial wire bending machines, the printer ejects a portion of wire that's bent in certain places. And during the process, electric motors are attached, which brings the robot to life. Due to an underlying algorithm, the machine can autonomously design a robot, upload the specs, and print the final piece. Also, the printer learns over time. When a certain design fails to perform, it will keep creating a different model until one finally works. This may seem wasteful in both time and materials, but the wires are easily recycled by straightening, and each robot takes only 15 minutes to print. That's all for this week's episode. Be sure to check out on Facebook and Twitter and catch past episodes on wirelessdesignmag.com. For the WDD channel, I'm Jennifer Della Osa. Thanks for watching.